Okay, so we're working on a new video for our Module 2 exam. So we're going to go over three problems in this one. We're focusing on scales, scale factors. So we're talking about the lengths of different sides when we talk about the scales. Remember, the scale factor is when we talk about the value of k, basically telling us how much we've increased or decreased the original image or item. All right, so we're on problem number 4. And problem number 4 asks us to use a scale of 1 inch to represent 25 miles. They want to know what the actual distance is between Orlando and Key West. They say that it's 392.4 miles. So, how many inches apart are the cities on the map? We need to round to the nearest 10. So remember when we're talking about scales, it is a ratio, so it has to be in a particular order. You have to list the scale item first and then the actual. So I put off on the side my S and my A, and then I'm just going to set up proportional relationships. Um, and then what I'm going to do is fill in the units from the story. So I noticed that we were talking about inches and miles, and we need those units to match on both sides. Now, what we need is what do I know about both the inches and the miles from the story? And then the last step will be trying to find out the missing piece of information. So we know that the map scale is 1 inch, which represents 25 miles. And then we also need to find something else in regards to either inches or miles. And they tell us 392.4 miles. So we're looking at this here. Okay. And so I'm going to put that with miles, 392.4. That means that we're looking for the inches, right? And that's what they asked us in the question. Um, so remember, we have those three methods that we can use. We can use the swing method where we can go from one side to another. We also have the cross multiplying method. And then we have the fish method, right? So we can use either of those methods for us to find the answer. Okay. In this example, I'm going to use the swing method. So I will start in the denominator since I have both pieces of information. And I usually draw my arrow just so that I know I was going to go from 25 to 392, which means I'm getting larger, but I don't know what number I would need to multiply to get 392.4 exact. So I'm going to actually swap and go this way, right? And I know that I'm going 392.4 to 25 means I'm getting smaller, which means I need to use division. And if I plug this information into my calculator, 392.4, and we're trying to figure out divided by some number, which I don't know, is going to give me 25. Remember, if you don't know this missing piece, you can always interchange those two pieces because these two pieces make the whole. Okay. So I'm going to say 392.4 divided by 25. That will give me 15.696. Okay. Remember, under the swing method, whatever I do to the bottom, I'm going to do that to the top if I'm going in the same direction. Right. So I've changed my direction. I went from right to left, and now I'm going from left to right. So the only thing that needs to change is my operation. I'm going to multiply now by 15.696. And when I plug that in times 1, I don't even need to do that. That should be mental math. 1 times any number should always give you that number. So X should be equal to 15.696. Remember your units. So we were talking about inches. Okay. Now go back to our problem because if you give this, you may get the wrong answer. And it's not because your answer is wrong, but it's because you didn't give them what they were looking for. So let's go back over here. And what they asked us is to round it to the nearest 10th if possible, if necessary. In this case, we do have a number that is greater than the 10th place. So what we're going to do is look at our tenths, right? And remember, your right-hand man is going to tell you what happens to your 10th place. So remember, 4 or less, we're going to let that number rest where it is. If it's 5 or more, then we're going to let it soar or rise to the next number. So X is going to be equal to, I'm going to keep the 15 points. And we're looking at our right-hand man to see what happens to the 6. So it is greater than 4, which means that our 6 will turn into a 7. So the correct answer for this one is going to be 15.7 inches. And this was problem number 4. Okay. So now we're going to move on to our next example. So we're working on problem number 7. And number 7, that out to the side. All right. So for problem number 7, what we're doing is, it's 2 parts. We have a pentagon, HIJKL. It is a scale drawing of pentagon ABCDE. They want to know what scale factor was used for us to get the pentagon ABCDE to turn it into HIJKL. So we're looking for scale factor. I noticed that was in there. And if we're talking about scale factor, I know that I need that formula. Scale over the actual should equal K. Remember that K tells us what we have done to the original, okay? So if K is equal to 1, that means we have the same size, okay? Remember that if K is greater than 1, then that means we enlarged it. And if K is less than 1, then that means we reduced the original. Okay, so there's a few tips for us to remember about that, okay? So now what we need to do is just plug in our information from the story. Before we do that, one important thing that I want to make sure that you remember is that if you are trying to find the scale factor, you have to have the same units. So looking at my image, I do see that I have centimeters and centimeters. Okay, so we're talking about the same ones. And when we're talking about scales, we need to make sure that we're using corresponding sides. So I'm going to use this side, which corresponds to this side here. Okay. So I'm going to put in the amount of the scale. Which one is the scale? I don't know. So let's go back and look at that again. They say that pentagon is a scale drawing. Okay. So this is the scale. And then this is your actual. All right. So our scale is going to be 18. Our actual is going to be 12. And when we do that division, we're going to come out with K. So 18 divided by 12 gives me 1.5. So this is what we should have. So what this means is that K is equal to 1.5, or if you got a fraction, you're going to get 1 1/2. What this means is that I took the original here and I increased it 1.5 times. So it's 1.5 times larger than the original. So for part A, our answer, I'm going to put here A, our answer is going to be 1.5. Now, in the second part, they want to know what is the value of X. And so where is X? Oh, it's down here. They want to know what this value is. And so we have to go and use the same formula. We're going to plug in the information that we know so that we can find the missing piece. Okay. So remember, we're looking at corresponding sides. And so we're looking at the bottom here and the bottom there. So I'm going to write that formula out again. Scale over actual gives me K. The scale is X. The actual is 18. And it's going to be equal to K. K is 1.5. Okay. So now what we want to find out is what is the value of X? And remember, the goal is always to get the X or the variable isolated, meaning by itself. So I don't have this isolated because I see a fraction or division, and I see an 18 over here. So how can I undo or get rid of whatever is stopping X from being by itself? Well, we know that the inverse operation of division is multiplying. So I'm going to multiply both sides by 18. And then what do we end up with? Well, if we use cross multiplication, 18 divided by 18 gives me 1, right? So I'm left with X, and that is equal to 1.5 times 18. So what is that answer going to be? You're going to just plug that into your calculator, 1.5, and I shouldn't have used an X for my multiplication. So see how it looks like it's a variable. That's why we start using like circles or parentheses, okay? So we're multiplying these two numbers, and when we do that, we should come out with 27, okay? Remember, something's missing, the units. Always, always, always put your units, okay? So this is 27 what? This is 27 centimeters. What we're saying is that X is equal to 27 centimeters, So we're going to do one more problem, which is problem number 8. It is a composite. And so on the composite, let's look and see what we have for that one. All right, so remember that a composite figure means that we just took more than one shape and put them together. And so it would look something like this. So it's something that we don't have a direct formula for us to use, but if we break it up or decompose it into shapes that we're familiar with and that we have a formula for, then we can find the area. So what we're doing is Rhea is adding a sunroom to her home. It shows what she's planning to build, and she wants to install outdoor carpet in the sunroom. They want to know how many square feet she needs for her to cover the floor of the sunroom. Let's see. What can we do to figure this out? Well, first thing I'm going to do is look and see what shapes do I know that I'm familiar with. So I'm going to look at this, and I see that I have a rectangle. And then I also see a polygon. Okay, so let's look at that. I'll write that out on here. It is a composite, so I'm just going to make a note of that. Let me know that it's more than one shape. And then I'm going to put those two shapes that I saw. So I saw a rectangle. And then I also saw a trapezoid. So the trapezoid is here. Ooh, that's horrible, but okay, so that is our trapezoid. So I'm going to do that. I'll put that off down here. All right, so those are the two shapes that we have, the rectangle and the trapezoid. So we know that the area of a rectangle is length times width. And what is our length? What is our width? So if we're looking here, we're going from here to here, we notice that it's 36. So our length is 36. And then if we're going from here to here, which in this drawing it will be from here to here, that's not correct because this is 28 going all the way to this side. But let's look, because it's a parallelogram, we can look on the opposite side and see what we see over there. So I noticed that on this side it's 20. So I'm going to multiply that by 20. That means 36 times 20. That's going to give me 720. 36 times 2 is 72. And then add a 0. So 720 what? Remember, units are important. Feet. What kind of feet? It's squared because we were talking about area. We multiplied the two sides. So we have the area of our rectangle. Now we need to go and find out the area of our trapezoid. So the area of a trapezoid is, remember, we're going to add the two bases, base 1 plus base 2. We're going to multiply that by the height, and then we're going to divide that by 2. So what is our base? When we talk about our base, we're talking about this side and this side, right? So I don't see a number here, but if I look, remember that was part of that rectangle. Look at the opposite side, and what do we see? We see that going from here to here was 36 feet. So I'm going to leave this as 36 and keep my A because I don't have the area yet. So I have 36 plus. This is going to be from here to here is 17. So we have 17. And then we're going to multiply by the height, right? So when we talk about the height, we're talking about the distance from the base to the peak, right? And I don't have that information, but what I could do is find the difference from the base all the way to the top, which we had up here as 28. Take out what I don't need, which is from here on down to there. And then I should be able to find out what this length is. So we knew that going from here to here was 28. Okay. I'm going to take out what I don't need, which is the 20. So let me put that off to the side. So I'll put 28 minus 20. That gives me a difference of 8. So that means that my height is 8. And let's see how this makes sense. So if this is 8 and this is 20, that would be, this is not a 1. Okay. This is just talking about the height. That would be 20 here, 8 here. Makes sense that this is a total of 28 feet for the entire height. So our height is 8. And then we're going to divide that by 2. Okay. So if we find out what those calculations are, 36 plus 17 gives me 53. And then I'm going to multiply that by 8. And then finally, I'll divide by 2. So 53 times 8 gives me 424. Remember, you can plug that into your calculator. And after that, we're going to divide that by 2. And that means that we have 212. Okay. So the area is 212. Are we done? No. We have to make sure that we have that unit. What kind of unit? Feet. Okay. Is it just feet? No. We talked about 2 sides. We multiplied 2 sides. So we are talking about square feet. So now I have the area of the rectangle. I also have the area of the trapezoid. So what do we do now? We're going to just bring them back in together or compose it. So the area of this composite is going to be the sum of the rectangular shape and the trapezoid. Our rectangle was 720 plus the area of the trapezoid was 212. So we are left with 932 what? Feet. What kind of feet? Squared. So that is the answer for number 8.